Okay, this is a synchronous work for chapter 7-2. Simon, and let's see, this is, let's see, is this the, okay, so this is, first one we deal with, I think assignment 7 33 7-1. There's a student who had a question about this, and we did during the class, but I came up the model answer. So let's do this, and I was going to look for a model, different kind of example, but let's use this, and let's see if I can come up the computer output example question next week. Okay, so this is the computer output, and when you answer this, you have to create the equation usually, and it's at least square the regression line is called line of best fit, right? And the first one, give the equation of the least square regression line, define any variables you use. So this is the formula, and this one you will see on your AP exam, and you plug in A and B here. A is constant, so you just plug in 1.14. This is a constant is showing up here. Okay, this comes coefficient. I don't know why it's same line. Sometimes it's different line. And it's a Cohen index. And if you read this one, there are two topics you can focus on. First one is the red squirrel offspring, and the other one is pine cones, the abundance of pine cones. Okay, so in that case, it's a Cohen index. That might be a pine cones, right? That might be the coefficient. It's a coefficient, right? It's right here. So you plug in those numbers, and this is a equation. Predictor of y hat, that might be offspring, is 1.4146. That's a constant, right? Plus 0.4399x. So all I did is plug in those numbers, okay? And you can define x and y hat. Now, is a linear model appropriate for this data? So you can look at the residual plot, and you could say it's good. And if it's strong or weak, if they ask strong or weak, you can run the square root, because they give you r square, right? So you can find r uh, to find the strings. And I did the R is 0.756. I think I calculated incorrectly the other class. So I make it very strong, but this is very strong, 0.75, okay? So, and you look at the residual plot, this is residual plot, so there is no pattern, so you can say this is straight, okay? Now, and if you convert residual plot to scatter plot, most likely it's this. This is really strong, maybe a little bit more scattered, okay? Oh, this is the one I used for period, maybe period 1 or 7 class. It's 0.93. I plug in incorrect number here, okay? Now, interpret the value of r square, ns. I didn't see this s. S is here actually. This is standard deviation here, okay? 0.60. So first one, the r square this is typical answer. You can go with your textbook, but this is my way of answering. 57.2% of numbers red squirrels offspring can be explained by the equation of y hat equal blah 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 blah, the same equation, okay? And where x is the index of the abundance of pine cones. So you define what x and y under this sentence as well, okay? Now, S is the standard deviation of the offspring, and so you can just write down from this tilde right here. We will typically be off by about 0.60 offspring. Okay, this is the first part of the asynchronous work. If you can take a look of your assignment 7-1, which is assignment 33. Okay, now second part is, I think some of the class we didn't do this work. So let me finish this one. So that's the reason why I said video. Okay. The polling organization asks the SRS, simple random sample, 1,500 first-year college students, how far away their home is. Suppose that 35% of all first-year students attend college within 50 miles of home. So some of you will be next year, it's going to be out of state students, out of city students, so it's going to be 50 miles away from home. So you might be staying in the dormitory, right? And or maybe you might be staying in your student housing apartment or something. Okay, so that is away from your home. Now, that is 35% average for the first year college student. Now, so the mean is 35, and the problem is to find the probability that the random sample 1,500 students will get a result within 2 percentage points of this true value. Show your work. So this is true P is given 35%. So I just put the decimal 0.35, 2 percentage above and 2 percentage below. This, the borderline could be here like this because we didn't run the standard deviation yet, right? So it's going to be, I just plugging around here. I know the answer key, so it's going to be around here. But if you get the standard deviation, you might have to move. If this is standard deviation is small, this line could be small. Wait, well, whatever. But you know what I'm saying. This is not the standard. This looks like standard deviation, but standard deviation is different. That's why I'm going to run this. This is what we did during the class and how we came up this. And if you didn't understand how we came up this, we can do the another asynchronous work. But and since they give you this, and they at the AP exam they will give you this formula, so we just plug in. Okay, standard deviation of the p hat equal square root of p, which is 35%, so 0.35, and 1 minus p, which is 0.65, right? Divided by n equal 1,500. Two things we have to check is this: large count condition and 10% of condition. 10% of what? 10% of first year college students, maybe for the United States. Is it 15,000 is less than 10%? Most likely, yes. If 15,000 less than first year college students in Los Angeles County, most likely yes, right? So we run, this is okay, 10% rule is okay. All right, second rule is large count condition. So what you have to do is 1,500 times 0.35. Did I do it? Yeah, here. Okay, that is, I don't know this amount, and this amount has to be more than 10. Most likely it's easy, right? So obviously this is going to be more than 10 both success and failure, okay? So that's the first thing, yeah. Check the condition first. Okay, now, after you run this, let's run the standard deviation. So 35, I'm going to say 0.35 minus, not minus, sorry, 1 minus 0.35, 0.65. So you multiply and divide by n, which is 1500, which is this. So standard deviation is 0.0123. So if I create, this is the bar line for this question, I create the dotted line, maybe dotted line. Oh, I'm sorry, this is not dotted. This is dotted line. So 0.123, 0.0123. So 0.0123, let me see. I use the calculator. So just get the estimate of 0.013 above. Let me erase this. Mean is 0.35. You add 0.0123. So that's one standard deviation, about 36.23. So it must be around here. That's the one standard deviation, 36. And second standard deviation above here. And we don't know this one, but most likely for this picture, it's going to be right here, right? So we're pretty much accurate this. So 35 minus 0.0123 is going to be 34. It's just right at 35. Wait, what did I do? 30. What? 35 minus, I'm sorry, 0. I'm so tired. Sorry, 0.35 minus 0.0123. It's going to be 0.3377. So this is a little bit over here. Did I do that? 3.3. So it's more like towards 3.4. Let me move this one to more 4 right here. Right. So this is pretty much accurate. And if you move another one, it's going to be left side of this. 1 standard deviation, 2 standard deviation, 3 standard deviation, 1 standard deviation, 2 standard, 3 standard deviation. Okay, maybe more like this. That's okay. But they're asking this. Let me change the color so you can see. They're asking only this red bar line. Okay, and let me highlight this section. So they're asking this probability right here. Okay, so it's between 1 and 2 standard deviation, below and over. So the cutoff line is 32. Wait, 32? I might be wrong. 2% of, so it's 36. So this is wrong. So let me correct this. So 33. Okay, so let me see. 33 is the cutoff line. So you run normal CDF. You plug in 33, not 30, 32, 33. And upper cutoff line is 37, 0.37. This is fine. Mean is 0.35. And standard deviation 0.012, maybe one more decimal. 0.0123 and paste. This is it. 89%. Okay, let's see the answer key. Okay, so okay, so everything is fine. You can read through this. They talk about condition here. They do not talk about 10% somewhere, maybe not. Okay, so larger than 10. Okay. Okay. Now they run this score here, but most likely it's the same way. So it's there. Okay. 0.8968. I think it's similar to mine. Oh, this one, normal CDF. 0.8961. Mine is, I guess it's same as this, right? Let me see. 8961, yeah. So you could interpret this one, the answer, about 90% of all SRS of size 1500 will give the result of 2 percentage points of the truth about the population. Okay, so that is it for chapter 7-2, and we're going to have chapter 7-3 next week. And I hope you have a nice weekend, and I will play a nice, I don't know if it's nice, but it's some music for you. Okay. This is Dizzy Gillespie's, it's called Com Alma. All right, have a nice weekend, and do your homework.